Cool.
All right.
So
go ahead.
This is the presentation that I put together. This is the personal one that I put together to sort of summarize the presentation that Google put together to summarize the release of Lit. So this is, we're a couple summaries deep here, but yeah, I'll share these slides at some point, but I'm not sure why this is not actually full screen, but I guess you can see all my browser Chrome, which is super cool. So this is Lit 2.0, and the briefest possible summary Lit element came out a while ago to sort of take away the sharp edges of dealing with native web components. It's just sort of with native web components, you need a little base class that extends the native HTML element, and Lit is that adds lifecycle hooks and all those sorts of things. So it's sort of just like a good foundation. So they released Lit 2.0, which is kind of a combination of their base class element as well as their template renderer. I'll show these slides. This is a link to the blog post that I am summarizing from, which is also kind of the summary of the video release. So you can link to that and see it. So the first thing that they wanted to talk about and I want to present is that the new Lit is smaller. So the templating part of Lit is 10% smaller. It's only 2.8 kilobytes. This is the part that makes the DOM and updates it. So it's kind of like JSX or in Vue world, HTML with the Vue directives mixed in. So it's that kind of stuff. So that's 10% smaller, 2.8K. The base class, which is Lit element itself, is 20% smaller, total of 5.2K. And that does actually include the templater. So when you include the base class, it includes the templating because you obviously have a render function in your base class. So this is the thing that extends HTML element. This is how you build components. So grand total of 5.2K basically to use this. So the better part, they've released a bunch of new things with Lit. They've just made some general templating improvements, just kind of cleaned up how you render more complex things like repeating elements and those sorts of things. They've just kind of sort of cleaned up how you might do that using some directives and stuff. They changed their directive API for authors to use a class-based API instead of a functional-based API, which if you prefer functional stuff, that might kind of be a negative thing, but it allows them to do a lot more like just cleaning up how it's used in the code and trimming things down. So the API may not be the best thing for you if you like functional stuff, but when you write a directive, it's easier to kind of manipulate on the code side. As far as using directives, no change at all. You just kind of drop them into elements and stuff. So they added reactive controllers. So basically, they noticed that a lot of people have a lot of logic that they need to share between components. And reactive controllers allow you to sort of abstract logic out to the controller level and allow a component to implement that controller without having to duplicate the code. The example they gave is just like a mouse position controller. Now, that may not be useful for everyone, but you can imagine you don't need to repeat the position of the mouse in every single component. They can just all implement the one controller. So. And then finally, they've created a thing called Lit Labs where they're working on things that aren't really production ready yet, but they're expecting to kind of get to, or maybe they're just seeing if it could work and maybe it'll just go nowhere. In this case, they have a localization feature where the standard localization format xlif is you can use it directly in your templates and components, and it will export all of your localizations to these xlif files to go out to translator sites or tools or whatever. So it's faster. I mentioned earlier that the base component is 20% faster, the templater is smaller, and the templater is 10% smaller. It's also faster. So they've not only decreased the size, they've increased the speed. It's 20% faster on the initial rendering times, and it's 15% faster on subsequent updates, which is pretty good. It was already 100% faster than Vue and React. So even faster now is a good story. So that's pretty good. And that link I linked to is actually a blog post from about 2 years ago. So everything has been progressing. So surely Vue and React got faster, but so did Lit. And then Lit also got faster again on this release. So the last one was server. We did faster, smaller Smaller, better, faster, and now it's server. The one kind of problem with web components that you could really point to was the inability to do server-side rendering. They require Shadow Dom typically to get like the real power of the encapsulation and those sorts of things. In order to solve that problem, they have been working on a number of specs as well as some tooling, and they now have the foundation for SSR. The two biggest things here are they have their own tooling for like front-end hydration. So like once the static stuff comes from the server, then you can rehydrate it on the front end. And they have a spec in play that's they want to get into the full spec. It exists in Chrome called the Declarative Shadow Dom. So you can now declare Shadow Dom in like typed HTML. You don't have to have JavaScript to spin that up. So you can say this piece of DOM is actually going to be the shadow for its containing web component. So you can actually read it like in English and it becomes encapsulated Shadow DOM, which is really, really powerful. Also, this is still in labs, but they're using some like potential unstable dependencies. And so that's why. So they're just kind of working on this, but it is there. So also some new things. This isn't like part of the library per se, but they have a new website, lit.dev, really easy to remember, really clean. It's got tons of examples in the docs, in the playground, whatever, where even if you're reading the docs, you can edit the code and see it live update on the website. So it's really cool. There's no compiler because this is all like browser native tech. So you can just like on the fly, it's changing the examples. They have a new package, npm install lit. It used to be, if you wanted the renderer, you'd lit-html. If you wanted the component, lit-element. Now it's just lit. You can import from the one package. A new source home for the base package, lit/lit on GitHub. And the org there that I put in parentheses is the top level lit org, but it's mostly just the lit package. And then of course a new Twitter handle with build with lit. Also, here's the video, and it just blocked the YouTube video. I haven't actually seen it presenting, but you see the little flash there as it tries to load it. There's a YouTube video embedded here in the page, or you can just click that link and it goes to the YouTube video. I can't move forward. There we go. The video has a surprise appearance by me, which is pretty nice.
Wait, what? Tweets or what?
No, so I asked a question and they put it up on screen.
Oh, nice.
And I talked about it. Yeah,
good.
So, and I think that's it. I think that's the end of the slides. So cool. That's it. That's basic the stuff.
Thank you. So that's pretty good to have that summary. And I'm wondering, so since they have the reactive new things, do they still have a full-blown virtual DOM engine inside the templater renderer thingy?
So they've never had a virtual DOM. The way that it's worked is they use the HTML template element to read in the markup, and then out of that they use JS tag template literals to know which parts can change, right? Because with tag template literals you get the list of like things that are not string and the list of strings, and so using those two pieces they instantiate what's called a HTML part and HTML. I think they're called parts. They're either called HTML parts or attribute parts, I believe. And those are really the two things. Okay. And some of them can change and some of them don't because they know which ones those are. And then when the data changes, they just go in and tweak the things that can change. So it's kind of like the Svelte model where Svelte like knows exactly which piece of the DOM can change and it's just gonna go update that. But using HTML templates and all those things to get the speed of it. So with the virtual DOM, you are going to build your entire virtual DOM, compare it to what's in the DOM currently, and then every node that has changed, you'll go update them. But the problem with that is you have the number of JavaScript that you have to compare is like n squared or whatever, because like every time you add a node, you have to compare it twice to the live one and the virtual one. Yeah. Whereas with lit element or lit HTML, really, you're only going to be comparing the things that are dynamic. So as long as you don't add any new dynamic things, there are no new comparisons to make because the static stuff just stays still. With the reactive controllers, you're just abstracting you're just abstracting behavior out of the component body itself to a piece of logic that has access to the component, but is not part of the component. So the component, it's basically like almost a class inheritance type thing, where like if the component has a controller, it can have multiple controllers, and the controller can then react to DOM changes or lifecycle hooks and maybe update the DOM or whatever it needs to do.
Okay. All right, this is interesting. This might be relevant to some discussions we'll have down the line.
Yeah.
But thank you so much for the overview. Do you have anything to add? Should we stop it here?
I think we should stop it.
Thanks, Thomas.
Yeah.